Computer vision has a global market of $48.6 billion. As Mark Zuckerberg predicted, computer vision is helping visually impaired people understand the content of images. Also, it is converting blurry images into high-resolution images. What other innovations are new in the world of deep neural networks on images? Join us to uncover the top 7 incredible computer vision projects of 2022. Number 7. Automation colorization using deep neural networks. What is computer vision? Simplified, it is the use of deep neural networks to develop human-like vision capabilities for various applications. For image colorization, one adds plausible colors to monochrome photographs or videos to make them visually pleasing and convincing to the viewer. The multiple ways to assign a color to black and white images and add perspective to original photos can greatly enhance and even redefine these precious moments. Nevertheless, the machine learning and deep neural networks that produce this excellent work of art are to deceive the viewer of the thin line between the past and present. Therefore, the colors could be constructed less accurately from the original work, and it can still pass as appropriate automation colorization. Aside from coloring old videos and pictures, there is still a lot that computer vision could do to help with our memories from the past. Did you know that there are high-resolution digital frames that can restore blurry and low-quality images? We will present more information on image restoration to you shortly. Number 6. RealTR, end-to-end scene graph generation. A group of pioneers in the Netherlands is making a computer vision tutorial to teach the steps to predict the relationships between elements and images. For example, a scene graph proposes a solution for an end-to-end connection between different objects in an image. The distinct graphs make the various objects more noteworthy, and a relationship is duly instituted. To have a better feel of RealTR technology, you should apply it to landscape and real estate images. Give us a thumbs up in the comments if you think this project would be helpful for photographers. Number 5. Video restoration. Using a video restoration transformer, or VRT, you can now restore and enhance poor quality videos. Whether compressed, downscaled, or noisy low-quality frames can be corrected with a VRT utilizing AI to restore individual frames by examining information from other frames. The VRT uses parallel frame prediction and long-range temporal dependency modeling to calculate the correct data that is required to restore the image to its full splendor. The results can be amazing. If you are new here, let us take this opportunity to invite you to subscribe to our channel. We have everything that you need about the future of tech. Number 4. OneShot Face stylization. Face stylization applies fixed styles to the input images that run through it. The process uses StyleGAN as a style mixing property to provide the paired data with the right datasets. JojoGAN is an example of the applications that work in this project. Indeed, the style can use references from animals and other organisms to control the overall image output. Style mapping is excellent, and we predict that its fine-tuning methods could be a primary source on NFT blockchains shortly. The face is not the only human body part that computer vision can recognize. Pathologists work with large amounts of data on the human body, blood, and organs. They sometimes require AI to identify patterns and look inside a person to diagnose. Fortunately, there is something called pathology classification that we will get into shortly. Number 3. Text recognition using OpenCV and Tesseract, OCR. Converting an image into text is easier with OpenCV and OCR. PDF scanners and Google Lenses use Tesseract to recognize text-based images. The project makes it easier to take information from an image and transform it into text-based data. OCR is a Google-backed open-source application that can identify text in more than 100 languages. You can also train it to identify many more languages when you get this application. When text on images can be identified, analyzed, and conveyed to the right sources, then the model for the project becomes helpful to many people, including visually impaired people. Mark Zuckerberg once said, "If we were able to build computers that could understand what's in an image and tell a blind person who otherwise couldn't see that image, that would be pretty amazing as well." Guess what, Mark? We are looking at computer vision projects that could adequately respond to this request. So your prediction of computer vision has come to pass. Number 2. Image animation using a first-order motion model. The model animates faces in videos and images. Therefore, a driving video maps its motion over static images to give it a realistic appearance. This model occurs through Python deep learning platforms. The project animates static source images through unsupervised region detection. The process goes through two stages: motion estimation and image generation. The approach works between object parts and dense motion, and it produces an optical flow along with a confidence map for the whole image. Number 1. Pathology Classification. Pathologists face classifying large amounts of data each day. The work often brought about more mistakes than they would like to admit. Now, there is a solution with these deep learning algorithms that can identify and separate large amounts of data into the required patterns and classification cases. Optical coherence tomography, also known as OCT, uses light waves to detect diseases to look inside a living body immediately. Healthcare has benefited from computer vision projects in many ways. For instance, during the COVID-19 era, a project called COVIDnet detected viruses in patients, thereby aiding in diagnosis, monitoring, and prescribing the appropriate treatments under the pandemic. As well, COVIDnet performed X-ray analysis, CT and MRI, digital pathology, cancer detection, and blood loss detection. As well, the light works with animals and plants. The evaluations evaluate and provide insight into significant chronic and minor diseases alike. Now that you know all about these projects, we can discuss how to provide lasting solutions to major societal problems through computer vision. Watch our video on how computer vision works to provide solution now.